For more on the coronavirus and its spread, we turn to biological engineer Dr. Shiva Ayyadurai.
This virus, the coronavirus, NCOV 2019, the reason some people may be proliferating that on the internet is because, these viruses mutate and they're a little bit different. This is the NCOV 2019 is part of a group of viruses called the coronavirus. And this virus is very similar to the SARS virus, except for around 1,500 nucleotide base pairs. So what I mean by that is if you look at the nucleotide sequence, which they've sequenced of the current coronavirus, it's around 29,000 base pairs. And there's about 1,500 people are saying we don't know where it came from, okay? So some people have used that unknowingness to start speculating, did it occur in nature or did someone stick it in? So that's where it's coming from. Because of that unknown nature of that 1,500 pieces of the base pair.
Well,
that's why.
Is there a way to know whether it was something that was in nature that obviously maybe we haven't discovered yet, or if it was something that was engineered with somewhere within a lab?
Well, it's all probability, right? Some people have speculated, like if you actually went into nature and you start looking at, remember, this is what's called a zoonotic virus, which means it came from an animal. For example, the SARS virus was started in a bat, went to what was called the dog raccoon, and then came to a human. The Middle East, respiratory syndrome virus, that came from a bat, then went into a camel, and then came to a human. What we know about this virus is that it's pretty clear it's very similar to the SARS virus, except for those 1,500 base pair sequences started in a bat, and the latest research I was just reading today, it's clear it went to a human, but after that went human to human to human. Typically, some of these viruses, the origin goes from animal to human, animal to human, animal to human, then human to human. But, the only way you could discover this is if you actually started surveying animals in nature and got entire libraries of their viruses and as they were recombining and started doing a probabilistic measure. It's frankly very difficult to do that unless you started creating data banks of what viruses were out there in nature today.
Why the bat? Because obviously this is the second direct link in recent time that is related to the bat being able to start this virus. Why that animal? What makes that animal so susceptible to this type of virus? Not only if it's in them or receiving it, but also being able to spread it. And if it's so bad, why have we not just, in good faith, just banned anything that involves having to eat a piece of bat?
Well, that's a good question. Well, first of all, you have to understand, in China, they have a much wider range, as everyone goes Googles, and people have been spending all sorts of crazy videos. If you just go look at the broad range of things that are sold in the Chinese market in China, it's not just people are selling cows and chickens and pigs. There's a whole range of things, including snakes and bats. Now bats fly, right? So they can transmit things in a much broader way. And so that's one of the reasons, right? And the fact is that they're in these closed market situations where all sorts of infections and disease can thrive and under certain conditions. One of the interesting things about, as I mentioned, SARS came from bats. So did this coronavirus come from bats. The interesting point here is both of these viruses, and this is what we should be aware of, both of these viruses, when they land on a cell, so when the way it works is think about the cell as a big bubble. When the coronavirus is a small bubble landing on that cell, and the way it attaches to that cell is, think about it like Velcro. There's a sticky portion on the cell, and the virus has another portion, and it can only land if they stick together, okay? And that sticking together is called a receptor. On the cell, it's the ACE2 receptor. The point is that receptor was also used in the SARS virus. The important thing to understand here is the infectivity rate is a function of how well the virus can land on that cell, and then once it lands, its two bubbles fuse, and that's called the infection rate. At the 520 or 519 base pair sequence, we should be concerned because if a mutation takes place there, this stickiness can occur much faster. So what's interesting about this virus is, one number, 17,000 people have been infected, 2% have died. With SARS, the death rate was 10%. With MERS, it was 30%. However, so it's spreading. It appears to be spreading faster, about 4 times, 2 to 4 times faster, but not as deadly. But again, we got to understand when SARS came out, there were 1 billion travelers. Today, there are 4 billion travelers. So this is, we have to keep all of this in context.
Well, and I actually like how you've explained it, because that leads to the last question. That's why I want to have you, before I let you go, I want to clear up this speculation that some were saying that this potentially could be because there was some sort of biomedical chemistry that was being done for weapon usage within the town and within the area. The way you just described it, this seems almost like nature is obviously responsible for this disease. So what is your theory when people come at you and say, what are your chances that this is actually a type of a bioweapon that has gone bad and gone rogue?
Well, look, if you wanted to actually use it as a bioweapon, right, you would there would be a lot more death rates. As of now, again, this is a moving story, right? Mm-hmm. As of now, 2%, the death rate is 2%, the mortality rate, right? Mm-hmm. It's not like MERS was, which was 30% out of the people that got infected, 30% died. The other important thing to note is when you really start looking at the cases, many of the people who died, except in one case of the one analysis of the 5 people were below the age of 60, everyone else was above the age of 60 and had some type of pre-existing condition. Look, when we look at the flu, every year maximum about 800,000 people get infected, 60,000 people die, which is a 7.5% mortality rate. We're looking at 2%. I'm not saying people should not be concerned. The countries are doing the right thing, isolating people. The more interesting thing that I'd be concerned with is, this is are we in the age of biomedia warfare, right? Where it's not, a country like China wants to impose on its people the concept that the uniparty, that they will take care of everything, right? Mm-hmm. So one thing to be concerned about is, can governments, if they want to, this is again pure speculation, right, put out a virus scare and then say how great they are at containing it, you see? And that can serve many different agendas. So it's a very interesting, if people want to think about it, how does a virus news and how does media come together to talk about news versus we're not talking that much about the flu, right? We're not talking about many other things which are have a much, much higher death rate, right, much higher, infectious rate. So why is this receiving so much news? And I think that's a more interesting thing. And what does that mean for public policy? What does that mean to what was going on in Hong Kong, right? There was these huge protests going on. We don't hear a lot about that anymore. Coronavirus has come to the forefront, and that has become diminished relative to the news cycle.
Well, and you also look at the pharmaceutical companies that are obviously getting government grants to try to research viruses or to find solutions for it. There's all sort of, unfortunately, politics that play into all this. It sometimes doesn't actually find the cure and help the people who are being affected by it. But you're right. It's never just, unfortunately, about the sick patients. There's always a lot more factors involved. Thank you for coming on today and continue to join us. I hope you continue to join us as we, unfortunately, this doesn't seem to be going away anytime soon. And hopefully you won't either. Thank you for joining us, Doctor.
Okay, be well. Thank you.